we are going to discuss second formula, that is section formula. So this formula is used to find the ratio between any two points when they are divided by a given point. For example, consider any two points A and B, and we are assuming that this P point divide AB internally in ratio M1 ratio M2. So we can simply find the ratio, that is M1 ratio M2, using section formula. So here PA upon PB equals to M1 by M2. Now you can check that triangle PAQ and triangle PBC. You have to check these triangles. First of all, let's take construction part. We have construct AQ perpendicular on this line. Similarly, PC perpendicular on this line, BT. And here, AQ is parallel to RS and PC is parallel to x-axis. Simply you can say AQ and PC both are parallel to x-axis, and we have drawn two perpendiculars. AQ perpendicular on PS and PC perpendicular on BT. Similarly, AR perpendicular on x-axis, PS perpendicular on x-axis, and last one BT perpendicular on x-axis. Now, triangle PAQ and triangle BPC, these two triangles are similar by angle-angle criteria. So here we can say that PA upon BP equals to AQ upon PC equals to BP upon BC, and this is equation first. Now check AQ equals to RS. Yes, AQ equals to RS, or you can say OS minus this part OL. If we subtract OR from OS, then we get RS, and RS also equals to this X minus X1. Similarly, PC equals to X2 minus X. You can also check this PC here. PC equals to X2 minus X. Now next one, PQ, that is equals to yes, PQ. Here you can write PS minus SQ equals to PQ, and PQ lies on y-axis. So you can say that PQ equals to X1 minus X. Y minus Y1, because it lies on y-axis. So you can say PQ equals to Y minus Y1. Now BC, that is BC, here BC. Again, BC lies on y-axis. So you can say that BC equals to Y2 minus Y. Now, we have to put these values in equation first. Here, in place of PA upon PB, we can write M1 by M2, and these AQ, PC, PQ, BC. Substitute these values here in equation first. So we get this, that M1 by M2 equals to this in terms of x-axis, similarly in terms of y-axis. We get these relationships. Now, first we have to multiply these. So using cross multiplication, we get x equals to M1 x2 plus M2 x1 by M1 plus M2. Similarly, M1 by M2 is also equals to Y1 minus Y minus Y1 upon Y2 minus Y. So using these two cross multiply, we get this result that Y equals to M1 Y2 plus M2 Y1 by M1 plus M2. So these are the coordinates of point P, X and Y. So this is section formula that is used to find the ratio. Take example for section formula. Find the coordinates of the point which divides the line segment joining the points P, 4, minus 3 and 8, 5 in the ratio 3:1 internally. So here we are having a line. Let's take this A, B, so 4, minus 3 and B, that is 8, 5, which is divided by point P whose coordinates are X and Y, and the ratio is 3:1. So here M1 equals to 3 and M2 equals to 1. Now using section formula, That is x equals to m1 x2 plus m2 x1 by m1 plus m2. So put the values m1 3 and here x2. This is x1 y1 and this is x2 y2. So m1 into x2, so 3 into 8 plus m2 into x1, that is 1 into x1. x1 is 4. So you can roughly write m1 equals to 3, m2 equals to 1, x1 equals to 4 and x2 equals to 8. y1 equals to minus 3 and y2 equals to 5. So by using this, you are not getting confused. You can simply put the values m1 x2, that is 3 into 8 plus m2 x1, that is 1 into 4 by m1 plus m2, that is 3 plus 1. So get the result x equals to 7. Similarly, y equals to m1 y2 plus m2 y1 by m1 plus m2. Put the values and get the results. So here, coordinates of p, that is x and y, x equals to 7 and y equals to 3. Let's take another example. If the points A 6, 1, B 8, 2, C 9, 4 and D P, 3 are the vertices of a parallelogram taken in order. So we have to find the value of P. So here A, B, C, D is a parallelogram and its coordinates are given to you. Now you have to find the value of this P. First of all, we know that diagonals of parallelogram bisect each other. So OA equals to OC and OD equals to OB. Now, if this is the common point for AC and BD, so we can say that coordinates of midpoint of AC and coordinates of midpoint of BD are equal. So, first of all, midpoint of AC, that is 6 plus 9 by 2 for x-axis and 1 plus 4 by 2 for y-coordinate. Similarly, for BD, 8 plus p by 2 and y-axis 2 plus 3 by 2. So these are x and y coordinates for midpoint of AC and these are xy coordinates for midpoint of BD. Now solve it, equate these and get the value of p. So here in this case p equals to 7. So here using section formula, that is m1 x2 plus m2 x1 by m1 plus m2. Get the coordinates of x. Similarly, get the coordinates of y, m1 y2 plus m2 y1 by m1 plus m2. Get the coordinates of x and y. Now, it is given that find the ratio in which y-axis divide the line segment. So, if the point lies on y-axis and we know that on y-axis abscissa equals to 0, then we can say that this part, that is x coordinate, becomes 0. So minus k plus 5 by k plus 1 equals to 0 and using this we get the value of k. So here k equals to 5.